Hey guys, this is your video for systems of equations with word problems. And so we are just trying to solve this word problem here when you have two systems. Okay, so we're going to be writing some equations that can graph these things. We can check them with our calculators. We can do all that good stuff with this if we take our time and see what's going on with our stuff. So here's our first question that we are going to do. You have two scenarios. You have option one, which will be my first system, my first equation, and you have option two, which is where I'm going to write my second equation. Now before we start writing our equation, we want to take a look at these things and see how can we write these things using our organizer there if we need to, our start, change, and finish, what we have. And to help me find out what my change will be when I read my first one, it says I can pay $5 per visit at the Edge ice rink. Well, I had the word here per. Per means change. And so what that means is telling me is that my change here is going to be 5. And it has the x value with it. My start value here is 0. I don't have anything to pay for my start value, so it becomes 0. And my finish is y. And if I want to take that out of my start, change, and finish, I know that my equation is y equals 5 times x. So there's my first equation that I needed to do. Now I need to write my second equation for my second option so I can have 2 for my system. So if I read this here, it says I can pay a 1-year membership of $40 plus pay a $1 each time I go to the skate rink. That word right here, each tells me my change. That is what's changing. So that will go in my organizer when I write my equation, my start, change, and finish, as right here, 1x. So we notice here that when we have the word each or the word per, they become my change words. Those go in my change and have my x. Well, what do I need to start with? I started with $40. So I pay my $40 fee. I pay $1 every time I go. That's what's changing. My price changes by $1 every time I go. And I have my equation 1x plus 40. So now I have my two equations. Here's my first one, and here's my second one. Okay. Now I'm ready to start to solve my first equation, my first question. It says question 1 says, which option is cheaper if I go to the edge 20 times? That means I have 20 visits. I visit the edge 20 times. Now, how can I use that 20 and these two equations to figure out how much it would cost me to go? So let's think about it. If I go for the first time, I have my equation. It says the cost is going to equal 5 times the number of visits. Well, how many visits am I going on the first one? Well, I'm going 20. So I know that I need to take my first equation, 5x, and I'm going to put the 20 into the x spot because that represents my visits. So I have y equals 5 times 20. When I do 5 times 20, that gives me $100 for 20 visits for option 1. If I do the same thing, I got to check now which option, because I have 2, so I got to check the second one here. So my second option was y equals $1 for every visit, plus the 40 to begin with. I want to know how much would it be with this option for 20 visits. So my x here is the visits, 20 visits. Every time I go, I got to pay $1. I'm doing it 20 times. So it becomes 1 times 20 plus 40. Now I can be able to solve this by doing my math. 1 times 20 is 20 plus 40 gives me $60. And I had $100 for the first option. So which option here is the cheapest? Well, obviously option 2 is the cheapest because it's only $60. So that would be my selection there. So if I want to go to the edge 20 times, I would select option number 2 because it only cost me 60 bucks, while this one cost me $100. So that would be my solution there for that first question. Now my second question here is I can solve this as I want to know when will they be the same. This means I want to know where will they be where they have the where would the intersection point be? Intersection point. Where is the intersection point between my two equations that I have? And I can do that either through substitution, and I can do that either through graphing on my calculator. Either one of those will work. I'm going to do both of them so you can see. Okay? So my substitution method, when I do this one, is I'm going to set my two equations equal to each other. So what I have there when I have, remember I want y equals y, and my first y here is 5x. My second one is 1x plus 40. And I want to solve that equation here. So when I solve this equation here, I'm going to subtract 1 on both sides, get my x's on one side. See how I've separated my x's now? Because I have 4x is equal to 40. I've separated my x's in my numbers. X's are on one side, numbers are on the other. Then I can divide by 4 because that's times. And it says, oh, if I go 10 times, so it gives me x equals 10. That means 10 visits. Well, what would be the cost? That's my y value. So I need to take this 10 and put it into my first equation. Y equals 5x. How much would it cost per visit? Well, I'm putting that 10 into here. It becomes 5 times 10 equals 50. So $50. So my 10, 50 is my answer there. 10 visits, $50. Well, how could I graph that? Maybe you don't want to do substitution. You can graph it. Well, the same thing. I can pull out my calculator here, make sure I turn it on. I'm going to put in my two equations that I have. There are my two equations right up here. So put it in here. So I have 5x in x plus 40. I put them into my thing. Zoom 0. There they go. So I want to know what is this spot right here. I'm going to hit second trace, number 5, enter 3 times. 1, 2, 3. And I get my solution down here at the bottom. It says 10, 50, just like we solved right here. So I know at 10 visits, they will be the same, and the cost will be $50. So that's my answer for number 1. And that's kind of what you'll be looking at here when you're doing these problems. Okay? So let's look at one more, and then you'll be doing some here on your own. You'll be doing the rest there on your own. Okay? So if I take a look at my next one here, it's on number 2. Let me get another piece of paper here. One second. There's the first one there. So what I want to do is I can solve these either by substitution or graphing, but I need to write my equations first. So I look at my problem here. It says $10 per. Uh-oh, well that right there tells me that's the change. So if I write my first equation using my organizer here, I have 10x. And what was the start? Well, I don't have anything for my start, so it's 0. So my equation there is y equals 10x. That's my first one. My second one here is I have $5 per day, and they charge me $20 for a one-time fee. Notice I have the word per again. Per means change. Each means change. Every means change. Those will be there for you. So when I put those there in my equation so I know which one gets the x value here, it becomes 5x is my change. My start fee is $20. So my equation when I take that out is y equals 5x plus 20. Now I have my two equations. And I want to know, what will it be, which one's cheaper in the first one for 3 days? So I want to know which option's cheaper. Is the first option going to be cheaper when I only pay $10 a day? Or will the second option be cheaper when I pay $5 a day plus a $20 to begin with? So what I'm going to do is I'm going to take that 3 and he goes into x. Because x is 3, x is the same. So I'm going to put those in here and I get y is equal to 10 times 3. What's 10 times 3? Gives me 30. So that option cost me $30. I do my next one. I say y is equal to 5 times 3. X is, that's for our days, plus 20. 5 times 3 is 15. Plus 20 gives me 35. So I look and compare which one's cheaper. Option 1 was $30. Option 2 is $35. So who's cheaper? Obviously this one is. Option 2. Option 1 is the cheapest one. $30 is better than 35. So I've solved that equation. All I did was just substitute in and solve that. Okay? Part B is asking me which one is going to be, where will they be at the exact same price? Where would they be at the exact same price? So I can use substitution method by setting them equal to each other, or I can use my graphing calculator. Either or will work. I'm fine with however you want to solve it. If you do substitution method, you'll take your two equations, and remember you want to be y equals y. 10x is my first y. What does that equal? My second y, 5x plus 20. I can then solve this by getting my x's to one side and keeping my numbers on the other side. That is my division line. So I need to move the 5 by, that's positive, by subtracting. And I get 5x is equal to 20. 5 times something is 20. Well, that's 4. Now I need to know what my y value is. So I'm just going to plug my y value back into any one of these two equations. I'm going to use the easy one. Y equals 10x. So 10 times 4 is 40. So my y is 40. So my solution there would be 440. So it would be 4 days at $40. What if you wanted to do the graphing? Well, if I wanted to do the graphing way, I just take my calculator here, put in my two equations, which were 10x, my second one, 5x plus 20, zoom 0. There's my first line. Here comes my second one. Now to find the intersection point, which we know is 440 already, but let's just see, would be second trace, 5, 1, 2, 3, and I get my solution to be there, 440. It gives me there right there. So if I graph it, I also know that it's 4 days at $40. So I can do them both in both ways. So we have just walked through two of them. You now have number 2 to do, 3, 4, and then there's 5 and 6. Just the same way, setting those things up and understanding what happens. We'll find the words that mean change, like those, every. And number 3, per. Set up your organizer just like we did so you can use your thing. Each. Those are words that mean change. Those are the ones that have your x value. On number 5, if you look at it here, each, per. Those are all words that mean change that will have your x value. The other numbers are just your start. So practice writing your equations Use your other two examples that we just did to help you solve these things, and you'll do a great job. Thank you. Have a good rest of the day.